I've always hated walking. So, as a kid, I used to beg my parents to buy me a pair of Heelys. These things were amazing. I used to ride them all the time in the mall, never had to walk, and honestly, I ended up getting pretty good at them. Now, I think it's time to move on to something a little bit bigger. I'm not a kid anymore, and I've outgrown these. So now, let's do something else. Let's make these electric. Now, fitting the motor and battery and all the parts into a shoe is going to be pretty difficult. But, as Nelson Mandela once said, it seems impossible until it's done. So, let's do it. So, what I'm going to be doing is I'm going to be using size 12 shoes, because that way I can fit everything inside the sole of the shoe, because I don't want anything peeking out of the shoe or showing up. So the first step in making these electric Heelys, first up, I gotta remove the sole, because the problem is, once I put all the electronics in here, I can't just cut it from this side of the shoe, because then all the electronics are going to be exposed and stuff like that, and I really don't want to be scraping them on the ground or have anything accidentally fall out. So the first thing I want is I'm going to want to remove the sole of the shoe, and that way I can put all the electronics in from the top in, and then I can only just show the wheel of the Heely peeking out.
Now, I'm no shoe expert, but here's the basic plan. Take this pot of boiling water, pour it into the shoes. That's going to weaken the glue, that way I can go ahead and remove the soles. Now, if these were any other shoes, I could have just removed the bottom of the soles from the shoe. However, these are Heelys. They're a little bit different. So instead, I gotta heat them up from the inside out. So I'm gonna pour this water into the shoes, and while the water is still hot, I'm gonna remove the soles while the glue is still weak. So now that I have the soles pulled out of the shoe, let me show you how everything's gonna fit. So the wheel's gonna fit right here. Then, to power the wheel, I'm going to put a motor right into the side of the shoe. And for that, I'm going to have to drill a hole. So I just kept drilling and drilling until I realized there were actually better ways. So I got set up and went back at it, this time using heat to actually burn the rubber. And that's when disaster struck. As you can see, I ended up burning my thumb a little bit there, so definitely wear gloves when you do this type of stuff. However, this actually wasn't my biggest problem. The biggest problem actually happened with the motor. See, when it spun around, it rubbed against the rubber of the shoe, causing extra friction that wasn't needed. So, to fix this problem, I started looking at things that I could use to cover the motor, such as this 6-volt battery case. The plan was that with some sort of casing like this, I could reduce the friction caused on the motor and allow the motor to spin just as fast. Now, time to keep going. So the next step is actually to drill out the sole of the shoe. This way, I can get the battery to fit inside. Now, this step took a lot of time, and that also means that it took a lot of rubber. So, there was a lot of smoke coming out, so I tried using a vacuum cleaner to actually suck up the smoke. However, as you'll soon see, I ended up moving to the garage because the smoke was too much to stay indoors. And this was the final product, a shoe with a hole drilled into its side and just enough space drilled out of the sole for a battery to fit snugly inside. As you can see, the battery fits perfectly, and there's even space for my foot to still fit inside the shoe. And now, it's time to go ahead and put all the electronics in. So this is the battery. This is what's going to power everything. This is a 3S LiPo, so it's going to deliver 11.1 volts, which is plenty of power to actually spin this motor. And this is the receiver. This is what's actually going to go ahead and get the signal from my remote control and tell my shoes what to do. And this is actually the brains of the whole thing. This is the ESC, or the electronic speed controller. And what this thing does is it's actually going to go ahead and take the signal from the receiver, it's going to take the power from the battery, and it's going to send it all towards the motor. Now, this thing does get pretty complicated with voltages and currents and how that splits it up among components and making sure you don't want to overload it or anything. So we're just going to keep it simple and say this thing connects all the pieces together and allows them to work together. Now, before we start talking about the motor, I will say it gets pretty complicated. As you can see, there are actually 3 wires sticking out of it. So that's because this is actually a brushless DC motor. And all that really means is that there's nothing actually physically touching any of the components. So it's just copper wire creating magnetic fields and magnets. And this is where those 3 wires come into place. They actually turn on the different sets of copper wires, creating different phases of magnetic fields, causing the magnets inside to be attracted to different coils, which in turn causes the motor to spin. And finally, this goes ahead and takes us to the transmitter. Now, I know it's hard to believe, but this thing actually transmits the signal to the receiver. So this is what I'm going to hold in my hand, and it's going to go ahead and control the shoes. So after talking about all the parts, it's time to go ahead and connect them, Lego style. So now, with all the electronics working, I decided to put it in the shoe. And as you can see, everything fit inside the shoe pretty well. So the first things first, you can notice that the motor is actually surrounded by a PVC pipe and clamped down with a hose pipe. And the pieces I'm using there are actually part of the 6-volt battery. And remember, the 6-volt battery was originally going to surround the motor to reduce the friction. However, the PVC pipe ended up just making more sense, and it secures the motor down to the shoe pretty well. Inside the shoe though, everything is relatively out of the way, and this is the ESC, and it fits nicely up against the side of the shoe, and it leaves plenty of space for the battery to still fit inside. And then, as you can see, there is actually a little rubber belt attaching the motor to the wheel, so when I spin the motor, it spins the wheel. And with this, we're ready to go.
Now, with one shoe done, it was time to test it out. It was time to see if it actually worked. And it did. That worked. The shoe ran on its own. Now it's time to see if I can actually get in it. So yeah, that didn't work. And the problem for that is that the belt broke. And that means 2 things. First of all, the belt is way too weak. And second, I need to cut a groove inside the wheel. That way, the belt can fit inside of the wheel, and the wheel isn't actually pinching down on the belt, causing it to snap.
So yay, another build montage.
The shoe was done and the wheels were spinning. Now, time to do all that work again for shoe number 2.
I started drilling out the shoe. Then I put in all of the electronics. And then a little bit of testing.
Okay, the shoes are done, they're running, they're perfect, and by this time, I am super excited to finally try these out. So for now, enjoy this montage of me and my electric Heelys. So, the shoes are done, and these things have been battle tested as well. They look pretty good, and I'll be honest, I can definitely see myself wearing these. Now, the shoes in the video were not actually fully charged, and that's because frankly, riding these things on a full charge scares me. 15 miles an hour is more than enough for a pair of Heelys. Now, obviously there are some things I would change about this in the future. Probably change the motor for an in-runner motor, that way it doesn't cause friction as it spins. But other than that, I'm pretty happy with this project. So for now, I guess I just have to learn to do some tricks on these.